Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 3 video on the chapter of time and work, where I will solve some selected problems from the exercise 13A from the textbook of author RS Aggarwal. These problems are related to the general rules, the two general rules for solving problems on time and work that I have discussed in the part 1 video. So if you have not watched the part 1 and part 2 video, I strongly and highly suggest that you please watch those videos as well. Part 2 was about solving assignment problems of assignment number 1. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, I highly and strongly request and suggest that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the selected problems of exercise 13A from the chapter of time and work. Okay, so I've written down all the problems, selected problems on the canvas, and I have now kept enough space so that I can complete the solution for each problems. As always, I say that after solving a set of problems, always try to revise the key concepts and formulas that you have used or was used in solving the problems. This will provide a regular revision of the chapter concepts and formulas. And if you do regular revision, the things, the concepts and the information stays for a longer time in your memory. Okay, let's start solving the problems. Question number 2, this is from selected problems from exercise 13A from the textbook of author RS Aggarwal. Question number 2 says that Ravi can do a piece of work in 15 hours while Raman can do it in 12 hours. How long will both take to do it working together? So this is a pretty straightforward question. So I can say that now Ravi's what is happening? Okay, so Ravi's, now instead of writing Ravi and Raman all the time, let me abbreviate Ravi as RV. Let's say Ravi B RV and Raman B RM. Okay, now I can say that RV's 1 day's work, since it is given that in how many days, now not days in this problem, the time is in hours. So we must say that not days but Ravi's 1 hour work, that is the amount of work Ravi can finish or do in 1 hour, will be equal to 1 by 15, since the complete work, that is a piece of work, is completed in 15 hours by Ravi. So I can say Ravi's 1 hour work is 1 by 15 using the first general rule. Okay. Similarly, I can say RM's 1 hour work is equal to 1 by 12. So this implies that RV, Ravi and Raman's together, if they work together, there's 1 hour work. 1 hour work mean 1 hour work means the amount of work done in 1 hour is equal to 1 by 15 plus 1 by 12. 1 by 15 plus 1 by 12, 5 3 and 4 3, so it should be 60. Okay, so 4 plus 5 by 60, which is 9 by 60, which is 3 by 20. So Ravi and Raman's 1 hour work is 3 by 20. So using the second rule, using the second general rule, that if you know that if we know the work done in unit time, in this case the work done in 1 hour time is, if it is 1 by n, then the time taken to complete the work is n units. In this problem the unit is hours, so it will be in hours. So but before that we have to express the amount of work done in unit time, that is amount of work done in 1 hour time, as 1 by n. So 3 by 20 is nothing but 1 by 20 by 3. So now we can say that Ravi and Raman will complete the work in 20 by 3 hours. In 20 by 3 hours, now you can convert this 20 by 3 as a mixed fraction, which will be 16 and 2/3 hours. 16 and 2/3 hours is the answer. That is, when Ravi and Raman are working together, they will complete the work in 16 and 2 by 3rd hours. No. Why is it more than, sorry, not 16, but 6. 20 by 3 is 6 and 2 by 3. So 6 and 2 by 3 hours. Okay. Now I might be doing some calculation mistake while simplifying, or doing any in the process of multiplying or division or any kind of arithmetic manipulation. I might do some calculation mistake. If I will not really focus in that, but if I do any calculation mistake, please do let me know in the comment section. I will appreciate that. Okay, let's do the question number 3. A and B working together can finish a piece of work in 6 days, while A alone can do it in 9 days. How much time will B alone take to finish it? Okay, so how much time will B alone take to finish it? The idea is that we have to find the amount of work done by B in 1 day. Then we can, from that information, we can easily say how many days B will take alone to finish the work. So first we have to find what is the amount of work done by B in 1 day. Okay, so it is given that A and B working together, that is A plus B's, we can say A plus B's 1 day's work is equal to 1 by 6. Since it is given A and B working together can finish the piece of work in 6 days. So in 1 day, the amount of work done will be 1 by 6 using the first general rule. Okay. It is also given that A alone can do it in 9 days. So we can say A's 1 day's work is equal to 1 by 9. Now A plus B's 1 day's work is equal to 1 by 6, and A plus B's 1 day's work means A's 1 day's work plus B's 1 day's work plus B's 1 day's work. Now we know A's 1 day's work is 1 by 9. So we can say that 1 by 9 plus B's 1 day's work should be equal to 1 by 6. So this implies B's 1 day's work will be equal to 1 by 6 minus 1 by 9, which is equal to the LCM will be 18. So 3 minus 2 divided by 18, which is 1 by 18. So if B's 1 day's work is 1 by 18, we know using the general rule, using the second general rule, we can say that B will complete the work. B will complete the work in 18 days. The second general rule says that if the work done in 1 day is 1 by n, then the total work will be done completed in n days. So the answer is that B alone will complete the work in 18 days. Okay, let's do question number 5. A, B, and C can do a piece of work in 10 days, 12 days, and 15 days respectively. How long will they take to finish it if they work together? Okay, so it is given that A's 1 day's work is equal to 1 by 10. Since it is given A can do the piece of work in 10 days working alone. So in 1 day, the amount of work done by A will be 1 by 10. Similarly, B's 1 day's work will be equal to 1 by 12, and C's 1 day's work will be equal to 1 by 15. Now, using these three information, we can say that when A, B, and C are working together, when they work together, that is A plus B plus C working together, then the amount of work done in 1 day by all of them working together will be, that is A plus B plus C's 1 day's work will be the sum of the individual work done by A, B, and C in 1 day. So 1 by 10 plus 1 by 12 plus 1 by 15. This is equal to 6 plus 5 plus 4 divided by 60, which is equal to 15 by 60, which is equal to 1 by 4. So now we can clearly say that whenever we know that the amount of work done in 1 day is 1 by n, we can say that the total work, that is the whole work, will be completed in n days. So A plus B plus C will complete the work in 4 days. In 4 days. So 4 days is the answer. Okay, let's do problem number 6. Okay, it says that A can do a piece of work in 24 hours while B alone can do it in 16 hours. Okay, so this time the time is in hours. If A, B, and C working together can finish it in 8 hours, in how many hours can C alone finish the work? Okay, so the time taken by A and B to complete the work working alone is given, but the time taken by C working alone is not given, and we have to find that. It is given that when A, B, and C, all of them work together, they finish the work in 8 hours. Okay, so let's first write down what information we have. So A can do a piece of work in 24 hours. Using the first general rule, we can say that A's 1 day's work is equal to 1 by 24. Okay, now it is also given that B alone can do it in 16 hours. So we can say B's 1 day's work is equal to 1 by 16. Okay, and it is also given that when A, B, and C are working together, they can finish the work in 8 hours. So we have A plus B plus C's 1 day's work will be equal to 1 by 8. Since A, B, and C working together can complete the work in 8 hours. So we can say that in one day, using the first general rule, we can say that in one day, amount of work done when A, B and C are all working together will be 1 by 8. So we have these three information. From these three information, we have to find what is, first we have to find what is C's 1 day's work. Okay. Now from these, we can say that A plus B plus C's 1 day's work means A's 1 day's work plus B's 1 day's work plus C's 1 day's work. This is equal to 1 by 8. Now we know the values of A's 1 day's work and B's 1 day's work. So we have 1 by 24 plus 1 by 16 plus C's 1 day's work is equal to 1 by 8. So this implies that C's 1 day's work will be equal to 1 by 8 minus 1 by 24 minus 1 by 16. We have to simplify this. The LCM will be, I guess, 48. 48. So 6 minus 2 minus 3 by 48. This is equal to 1 by 48. So in one day, the amount of work done by C is 1 by 48. So we can say that C alone will complete the work in 48 days. In 48 days, since the amount of work done by C in one day is 1 by 48, so using the second general rule, we can say that the total work will be completed by C alone in 48 days. So after this step, we are concluding this. Okay. Let's do problem number 8. A and B can finish a piece of work in 16 days and 12 days respectively. Okay. A started the work and worked at it for 2 days. A started the work, that is A was doing the work alone individually and he worked for 2 days. Okay. He was then joined by B. Okay. Find the total time taken to finish the work. So definitely after working for 2 days, A did a part of the work, some amount of work, which is obviously not the complete work, but some amount of work in 2 days, and the remaining work was done completed by B. So what so the number of days B was able to complete the remaining work, that number of days plus 2 will be the total time taken to finish the work. Okay. So what do we have? We have A's, since it is given, A can finish the work in 16 days. So A's 1 day's work is, that is the amount of work done in 1 day by A is 1 by 16, and we have B's 1 day's work is equal to 1 by 12. Okay. Now A alone worked for 2 days. So A's 2 days work will be equal to, using unitary method, 1 by 16 multiplied by 2, which is equal to 1 by 8. So this is the total work done by A in 2 days. So this implies work left. The whole work is always 1. So the work left will be the whole work, that is 1, minus the work done by A in 2 days, which is 1 by 8. This is equal to 7 by 8. So 7 by 8 is the amount of work left which need to be completed by B. So we need to now next find in how many days B will complete the work amount 7 by 8. Now, so B, now you must, one information or concept you must always remember that, let me write it, no, I will write it at the end. So we have to find how many days it will take for B alone to complete a work amount of 7 by 8 when we know that in one day the amount of work done by B is 1 by 12. So the answer is B. I am directly writing the answer. B will complete 7 by 8 amount of work, 7 by 8 amount of work in 7 by 8 multiplied by 12. 12 is coming from the fact that in one day the amount of work done by B is 1 by 12. So this is this. So this is, after simplification, 4.2 and 4.3. So 21 by 2. 4.2, 4.3. Okay. So B will complete the 7 by amount of work in 21 by 2. It is coming fraction. Let me quickly check why it is coming as a fraction. I mean, there is no problem in coming the result as a fraction, but still I will check. So A's 2 days work is A's 1 day's work is 1 by 16. A's 2 days work will be 1 by 16 multiplied by 2, which is 1 by 8. So the work left will be 1 minus 1 by 8, which is 7 by 8. Okay. Now we need to find what is the time taken by B to complete the work of 7 by 8, which should be 7 by 8 multiplied by 12. 7 by 8 multiplied by 12. Because now, why the time taken by B to complete 7 by 8 amount of work is 7 by 8 multiplied by 12, because we know that B can complete the work alone in 12 days, which means that complete work means 1. So B can do one amount of work in 12 days. So definitely B will do 7 by 8 amount of work in 7 by 8 multiplied by 12 using basic unitary method. So 7 by 8 multiplied by 12 is 4.2 and 4.3, 21 by 2. Okay. So it's 21 by 2 days, which is equal to 10 and half days. 10 and half days. So this, therefore, the total time taken is total time taken to complete the work will be the 2 day was used by A. So 2 plus 10 and half days. This is equal to 12 and half days. So total time taken is 12 and half days to complete the work. Okay. Question number 9 says that A can do a piece of work in 14 days and while B can do it in 21 days. Okay. They began together and worked at it for 6 days. So both A and B was working on the work, was working for 6 days. Then A fell ill and B had to complete the remaining work alone. Okay. In how many days was the work completed? So we have to find the total time it took for A and B to complete the work, where it is given that after 6 days, for the first six days A and B was working together. Then after 6 days A left and B was working alone to complete the remaining work. Okay, so A's 1 day's work. A's 1 day's work is 1 by 14, and B's 1 day's work is equal to 1 by 21. Okay, so we have to find what is the amount of work done by both of them when if both A and B are working together. What is the amount of work done by them in 1 day? To calculate the total amount of work done by them in 6 days. So A plus B's 1 day's work, that is the amount of work done in 1 day when both A and B are working together. A plus B's 1 day's work will be equal to 1 by 14 plus 1 by 21. This is equal to what will be 7(2) and 7(3). 642 will be the LCM. So 3 plus y 42. Yes, 2. 42. This is equal to 5 by 42. Okay. Now we see that A plus B's 1 day's work is 5 by 42. Now we have to find what is the amount of work done in 6 days by both A and B. So A plus B's 6 days work, using basic concept of unitary method, we can say that A plus B's 6 days work will be equal to 5 by 42 multiplied by 6, which is equal to 5 by 7. Okay. So this is the total work done in 6 days when both A and B were working together. So what is the work left? Work left is equal to 1 minus, since the total work or the whole work is has the value of 1. So 1 minus 5 by 7, which is equal to 2 by 7. This is the work left. Now this amount of work, that is 2 by 7, has to be completed by B, and we need to find out how much time B will take to complete 2 by 7 amount of work. Using the direct result that I discussed in the previous problem, I can say that B will complete 2 by 7 amount of work in 2 by 7 multiplied by 21. Where is 21 coming from? It is given that B's 1 day's work is 1 by 21. It was given that B can complete the work in 21 days. So therefore, B can complete the work in 21 days, means the complete work means 1. So B can do 1 amount of work in 21 days. So therefore, B can do 2 by 7 amount of work in 2 by 7 multiplied by 27, which is 6 days. So the remaining work will be completed by B in 6 days. So therefore, total time taken to finish the work is equal to 6 days plus 6 days. For the first 6 days, A and B were working together, and then the remaining work was completed by B alone in 6 days. So this is equal to 12 days. 12 days is the answer. Okay, let's do problem number 10. A can do 2/3 of a certain work in 16 days, and B can do 1/4 of the same work in 3 days. In how many days can both finish the work working together? So this is a little bit conceptual problem. Whenever you are given, normally it is given that A can do a piece of work in, let's say, in days. It means that a piece of work means the whole work, and the whole work is always represented as 1. So you can consider, whenever it is given A can do a piece of work in n days, you can consider it as A can do one amount of work in n days. So here it is given A can do, so you can say that A can do two-third of work, two-third amount of work. A can do two-third amount of work in 16 days. Or I think it will be more easy to say that, so it is given that amount of we need to actually find what is the work done by A and B in one day from the given fact. So we can say in 16 days A's work is equal to 2 by 3. Now when it is given that A can do a piece of work in, let's say, 20 days, then we can say that in 20 days A's work is 1, because in 20 days A is completing the whole work, and whole work is always 1. But in this problem it is given that A can do two-third of a certain work. Now two-third of a certain work, the certain work is always 1. So the two-third of a certain work, that work is 2 by 3. So we can say in 16 days A's work is 2 by 3. So using basic concept of unitary method, we can say in one day A's work will be equal to 2 by 3 divided by 16, which is 2 by 3 multiplied by 16, which is 1 by how much? 24. So as you can see that it is coming that in one day A's work is 1 by 4, which essentially means that A can complete the whole work in 24 days. Okay. So similarly for B, we have in 3 days. Okay. So in 3 days, B's work is given to be 1 by 4. Okay, so this implies in one day B's work will be equal to 1 by 4 divided by 3, which is 1 by 4 multiplied by 3, which is 1 by 12. So in one day amount of work done by B is 1 by 12, which essentially means that B can complete the whole work in 12 days. Okay. So now we can say that A plus B's one day's work is equal to 1 by 24 plus 1 by 12. This is equal to 1 plus 2 by 24. This is equal to 3 by 24. This is equal to 1 by 8. So clearly now we can say that A plus B will complete the work in 8 days. Since using the second general rule that if the amount of work done in one day is 1 by n, then the whole work will be completed in n days. So A and B, when working together, will complete the work or finish the work in 8 days. Okay. Let's do problem number 11. A, B and C can do a piece of work in 15, 20 and 15, 12 and 20 days respectively. They started the work together, but C left after 2 days. So for the first 2 days, A, B and C, all of them were working together, and then C left. In how many days will the remaining work be completed by A and B? Okay, so first the steps is that first we have to compute what is the remaining work. After C left, what is the remaining work? And then we have to find what is the amount of work done by A and B both in one day. From that information, we can then find how much time it will take by both A and B to complete the remaining work. Okay. So we have A's 1 day's work. A's 1 day's work is 1 by 15. Similarly, B's 1 day's work is 1 by 12 and C's 1 day's work is equal to 1 by 20. We also have to find what is the work done by A plus B in one day. Now, okay, so fine. So this implies we have to first find what is the amount of work done in one day by all of them. So A plus B plus C's 1 day's work will be equal to 1 by 15 plus 1 by 12 plus 1 by 20. This is equal to 4 plus 5 plus 3 by 60. This is equal to 9, not 9, but how much is this? 4 plus 5, 9 and 3, 12. So 12 by 60, which is equal to 1 by 5. Okay, so this implies C left after two days. That is, for the first 2 days, all of them were working together. So we need to find what was the amount of work done in the first 2 days. So A plus B plus C's 2 days work will be equal to 1 by 5 multiplied by 2. This is equal to 2 by 5. So this is the total amount of work done in the first 2 days when A, B and C, all of them were working together. So work left is 1 minus 2 by 5, which is equal to 3 by 5 is the work left, which need to be completed by A and B. Now let's see what is the amount of work done by A and B working together in one day. We can say that A plus B's 1 day's work is equal to 1 by 15 plus 1 by 12, which is equal to 4 plus 5 divided by 60. This is 9 by 60. This is 3 by 20. 3 by 20. So A plus B's 1 day's work is 3 by 20, and we also then how much time it will take by both A and B working together to complete the work left, that is 3 by 5. So A plus B will complete 3 by 5 amount of work in 3 by 5 multiplied by 20 by 3. Why 20 by 3? Because A plus B is 1 day's work is 3 by 20, which is basically 1 by 20 by 3. So whenever So whenever, which essentially means that A plus B can complete the work in 20 by 3 days. So if you have a single person or a number of persons, if a single person, let's say, can complete a work in n days, then the time taken to complete a certain amount of work, let's say p by q amount of work, will be p by q multiplied by n. That number of days it will take for that person to complete the p by q amount of work, where it is given that that person can complete the whole work in n days. So in this problem we are having, since we are having that A plus B is 1 day's work is 1 by 20 by 3, which essentially means that A plus B can complete the work in 20 by 3 days. So now what will be the amount time taken by A plus B to complete an amount of work which is 3 by 5? It will be 3 by 5 multiplied by 20 by 3. This is equal to 4 days. So the remaining work will be completed by A and B in 4 days. So 4 days is the answer. Okay. How many questions are left? This is the last question. Okay. Question number 12. A and B can do a piece of work in 18 days. B and C can do it in 24 days, while C and A can finish it in 36 days, which means that A and B working together can complete a work in 18 days. B and C, when working together, will complete the same work in 24 days, while C and A working together will finish the same work in 36 days. Now it is asked, in how many days can A, B, C finish it if they all work together. To find in how many days A, B and C will complete the work working together, we need to first find what is the amount of work done by all of them in 1 day. That is, when A, B and C are working together in 1 day, what is the amount of work. From there we can easily find in how many days A, B and C will complete the work. Okay. So we have that A and B working together can do a piece of work in 18 days, which means that we can say A plus B's 1 day's work is equal to 1 by 18. Okay, this can also be written as A's 1 day's work plus B's 1 day's work is equal to 1 by 18. Similarly, it is given that B and C can do it in 24 days. That is, B and C, when working together, can complete the work in 24 days. So we can say that B's 1 day's work plus C's 1 day's work is equal to 1 by 24. B and C working together can do it in 24 days. So we can say that B plus C's 1 day's work is 1 by 24. Now B plus C's 1 day's work means B's 1 day's work plus C's 1 day's work. So we have this. So these, let's say, this be result 1 or equation 1, this be result 2 or equation 2. Similarly, it is given that C and A can finish the work in 36 days. So we can write C plus A is 1 day's work, which means C's 1 day's work plus A's 1 day's work will be equal to 1 by 36. This is result or equation 3. Now if we add all the three equation or result, adding 1, 2 and 3, when we add an equation, what we do is that the resultant equation that we get is that the left hand side will be the sum of the left hand side of all the equations, and the right hand side will be the sum of the right hand side of all the equations. So we get, if you notice, if we add up all the left hand side, of all these three equations, the result, we will get 2 times A's 1 day's work, 2 times B's 1 day's work, and 2 times C's 1 day's work. So we are having 2 times uh, 2 times A's. We are having let's write it in a more clearly. We are having 2 times A's 1 day's work plus 2 times B's 1 day's work and plus 2 times C's 1 day's work will be equal to the sum of the right hand side of all the three equations, that is 1 by 18 plus 1 by 12, 1 by 24 plus 1 by 36. And what will be the value of this? I think the LCM will be 72. So 72, this is 4, this is 3, and this is 2. So this is 9 by 72, which is equal to 1 by 8. Okay. We have this. Now if you take 2 common from the left hand side, we get 2 times A's 1 day's work plus B's 1 day's work plus C's 1 day's work. This equal to 1 by 8. Okay. Now further simplifying the left hand side, we get A's 1 day's work plus B's 1 day's work plus C's 1 day's work means A plus B plus C's 1 day's work. So 2 into A plus B plus C's 1 day's work, that is the work done in 1 day when both A, B and C are working together. This is equal to 1 by 8. So this implies A plus B plus C's 1 day's work is equal to 1 by 8 multiplied by 2. This is equal to 1 by 16. So we get A plus B plus C's 1 day's work is equal to 1 by 16. So definitely now we can say that A, using the second general rule, A plus B plus C will complete the work, in 16 days. So 16 days is the answer. 16 days is the answer. Okay, so this brings to an end in solving the selected problems of exercise 13A. These problems are based on whatever concept we have learned, that is the 2 general rules for finding problems in time and work. The only topic left is how do cisterns and pipe work, their working principle, which is also based on, should be based on these 2 general rules. Now, regarding the key concepts and formulas that was used in solving these problems, let's quickly see what was the key concepts and formulas that was used. So this is, you should always do this, very important thing to do. Whenever you solve a set of problems, always write down, I know this might sound very redundant and boring, but please try to appreciate the fact that it will really help you in doing a revision of your previous chapters or the chapter concepts on the regular basis. So very important. What is very important? recalling concepts and formulas used to solve the problems. Now, obviously, the first two general rule is the fundamental concept that has been used to solve the problems. That is, if A can complete, let's not say specify a single person. Let's say in general, you can write it like this: if a piece of work, now a piece of work means a complete work. If a piece of work is completed in n days, this implies that one day's work, that is the amount of work done in one day, is equal to 1 by n. This is the first general rule. So this piece of work could be done by a single person, or it could be done by 2% or even 3%. In general, this is true. So if a piece of work is completed in n days, then in one day the amount of work done is 1 by n. The second concept is obviously the second general rule, that is, if it is a reverse of the first general rule, that is, if one day's work is 1 by n, it has to be in the form 1 by n. This implies total work will be completed in n days. Now, in some problems, the unit of time can be hours, but I'm just for the sake of discussion, I'm considering the unit of time is days. It could be hours, it could be days, it could be minutes, or it could be even seconds, or even years, or it could be months. Okay, so these are the two fundamental concepts that has been rigorously used will be used to solve the problem. So what else? Value of total work or a piece of work is always 1. Value of total work is always 1. Okay. 4. If let's say if let's say if 1 by let's say if p by q, where p by q is a fraction, a fraction means a proper fraction, that is p less than q. If p amount of work, p by q amount of work is done, this implies work left will be 1 minus p by q. And this is also important. If you have if 1 day's work, now this work, if 1 day's work, now this work could be done by a single person or 2% or even multiple persons. So if 1 day's work is 1 by n, it has to be in the form of 1 by n. So if 1 day's work is 1 by n, this will imply that p by q amount of work will be completed in P by Q multiplied by n days. So if it is known that the amount of work done in one day is 1 by n, then how much time it will take to complete P by Q amount of work? That will be P by Q multiplied by n days. So I think these are the main concepts that has been used to solve the problems so far. So I will end the video here. I hope this video was beneficial in applying the concept of the two general rules to solve problems of time and work. So if this video was beneficial, please like it, share it with your friends, and also once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video I will discuss about how do cistern and pipes, the working principle of cistern and pipes related to time and work. So that is the next topic and the last topic, and then I will solve the remaining problems from the exercise 13a. So that is all for this video. Thanks for watching, and until the next video, take care and bye.